In this web application, we're going to give you an example of hosting a Windows form inside a Synergy application. Synergy DE version 9.1.3 introduced the .NET Assembly API. This was a new feature available on the Windows platform only. Essentially, this API allows you to instantiate and interact with .NET types from within a traditional Synergy application on the Windows platform. The API allows you from within your Synergy application to load a .NET assembly, instantiate classes from within that assembly, reference and update fields that may exist within those classes, call methods that may exist within those classes, get and set properties, and even bind Synergy methods to events that may be raised within the .NET classes. There are basically two ways of using the .NET Assembly API. The first way is to use the API manually. In the Synergy runtime, there are 4 new classes that are included. These classes are called .NET Assembly, .NET Object, .NET Delegate, and .NET Exception. And programmers can write code to directly manipulate these classes, to directly reference .NET assemblies, objects within those assemblies, interact with their types, and so on. Using the API manually can be fairly simple if your requirements are very simple, but can quickly get very complex. The biggest downside of using the .NET Assembly API directly is that any application code that you write will not be compatible with Synergy DE for .NET in the future, as these types will not exist in the .NET runtime. The best solution, and the way that most people use the .NET Assembly API, is to leverage the new GENNET utility. GENNET creates Synergy classes which wrap or match the functionality of one or more underlying .NET classes. This generated code uses the low-level .NET API, but your application code uses these higher-level Synergy classes that mirror the classes present in the .NET assemblies that you're trying to use. The biggest advantage of this approach is that your code will also be fully compatible with Synergy DE for .NET in the future. At that point, you would simply be able to remove the wrapper classes that GENNET created and let your code directly use the .NET environment. In this session, we're going to present you with a demonstration. This demonstration will include 3 main parts. First of all, we'll use Visual Studio 2008 to create a .NET assembly, and that .NET assembly will contain a Windows form. The Windows form will include a graph control, and we'll show how that graph control can be displayed and driven from a Synergy application. Once we've created our .NET assembly using Visual Studio, we'll then go into Workbench, and we'll set up a Workbench project to show you how to use the GENNET utility to create Synergy wrappers for the .NET assembly that we created ourselves in Visual Studio. Finally, we'll use a second Workbench project to create a simple Synergy program which uses the wrappers that GENNET created in order to load, configure, and display the graph control in the Windows form. So here we are in Visual Studio. I'm using Visual Studio 2008 Professional, but other versions will work just fine. I'm going to be building an assembly that contains a class which is a Windows form. On the Windows form will be a bar chart control. Later, I'll be adding code to a Synergy application to display the form, and I'll be specifying the number of columns to display, the labels for each column, and the values for each column from Synergy code. To create a simple assembly in Visual Studio, we use a class library. So I'm going to use Visual Studio to create a new project, and I'm going to choose Visual C# as a language. If you want to use one of the other languages, that's just fine. And I'm going to use the class library project template. I've already created an empty folder where I would like my class library project to be created, and I'm going to name the class library .NET Forms. This will ultimately be the name of the assembly that I'm creating also. We'll go ahead and have Visual Studio create the project. You can see the project visible in the Solution Explorer. You'll notice that when you create a new class library project in Visual Studio, it adds a default class called Class 1 to the project for you. I don't want to use that class, so I'm going to close the source file, and I'm going to delete that class from my project. For our example application, we're going to be adding a Windows form to our assembly. So I'm going to select Project, Add New Item. I'm going to select the Windows Forms folder, and I'm going to use the Windows Form item template. I'm going to name my new Windows form Bar Chart, and we'll go ahead and add the new form to our project. As you can see, the form has been added to the project, and we can now see the default representation of the form. I'm just going to stretch out and resize the form a little bit to get it more of the size and shape that I want to use in my application. I want our Windows form to have a close button in the bottom right corner. So to help me achieve this, I'm going to go off and select from my toolbox a flow layout panel. A flow layout panel simply helps organize controls within an ordered way. I'm going to drop that onto the form. I'm just going to change a couple of its properties. I'm going to tell it to dock and therefore stick to the bottom of my form, and I'm going to select its flow direction as right to left so the buttons appear from the right hand side of the window. Next, I'm going to pick and drop a button into the flow layout panel, and you'll notice it gets arranged at the top of the flow layout panel. I'll resize the flow layout panel down so the button's going to stick nicely into the corner of the window. I'm going to set the name of the button control to btn close, and I'm going to set the caption text of the button to close. Now it's time to add the chart control to our Windows form. I'm going to choose to use the chart control that comes with the DevExpress suite of controls, although there are various other charts available and any of them should work just fine. The code might be slightly different. I'm going to drag the chart control onto the Windows form. When we do so with this particular chart, you'll notice that the chart wizard appears and allows us to do lots of different customizations to the chart control. I don't really need to do too much customization. I'm going to pretty much drive what's visible within the control from Synergy, certainly determining how many columns, the value of columns, the labels for the columns, and so on. So I'm just going to ensure that we do have a basic bar chart selected. And for our simple example, I'm going to go to Data Series. By default, the grid shows two columns of data, or two series of columns of data, and I'm just going to display one series of data. So I'm going to remove Series 2 from the control and click the Finish to close the wizard. You'll see the chart has now been configured just with one series of data columns. I'm just going to make one final change to this chart control. I'm going to set its dock property to fill the remaining space available within the Windows form. And that basically has the user interface of our Windows form that we're going to drive from Synergy complete. Now it's time to add a little bit of code to the Windows form to allow us to expose some behaviors or capabilities to Synergy. So what I'm going to do is I'm going to go and view the code behind the Windows form that we're creating. And nobody wants to watch me type a whole bunch of stuff, so I'm going to paste in some code that I created earlier. And now we'll take a look through what that code is. It's fairly brief. Basically, to the Windows Forms class, I've added a public property called title. And what this does is it allows me to access the title of the Windows form or set the value of the title of the Windows form from my Synergy application. I've also added a second property to the form, which is a Boolean property, true or false, called showLegend. And this basically will allow me to control from Synergy whether the legend in the chart control is displayed or not. And if I do wish to use a legend, by default it will be turned on. I also have a public property called legend text, which allows me to set the text for the legend for the first series of data, the only series of data as we know. We only have one series in our control. I've also added a public method. The method is called setChartData, and what this method allows me to do, as you can see, the method has two parameters, an array of strings, which are the labels to be used for the data columns, and an array of integers, which are the values to use for each column. You'll notice that as with most languages, arrays, when they're passed, the size of the array is determined by the caller. So this basically allows me to pass arrays of any size from Synergy. I could pass an array of 5 labels and values to get 5 columns,
12 to get 12, 20 to get 20 labels and columns, and so on. So Synergy can control the number of columns and the labels that are displayed simply by the size of the arrays that are passed into this method. And finally, we have an event handler for the close button, so that when the close button is clicked, the Windows form itself will be closed. Okay, we're almost done building our .NET assembly that contains now our Windows form class. There's one final change I want to make to this assembly. Well, not really to the assembly, but to the build process. I want to specify where the .NET assembly will get created. I'm going to ask that it be created in the same folder as the executables for my Synergy application. This isn't a required step, but I just tend to find it easier if the .NET assemblies and the Synergy executables are all in the same place. So I went to Project Properties. I'm going to select the Build tab within Project Properties, and I'm going to specify a location for the output path. I'm going to hit the Browse button, and I'm going to specify my exe folder. And as you can see, the folder is currently empty, and this is where I want to create my .NET assembly. It's also the same place later where I'll create a Synergy DBR to actually utilize and display the Windows form that we've created. So I'm going to select my exe folder, and then I can close the project properties. The final step now is to build the .NET assembly. So from the build menu, I'm going to select build solution, and in the output window down here you'll see that we have 0 errors, 0 warnings, build 1 succeeded. So I now have my .NET assembly created. In fact, if we switch quickly to Windows Explorer and look in our exe folder, you'll notice that there is our assembly.net forms.dll containing the Windows form that we're going to drive from Synergy very shortly. So, with our .NET assembly in place, it's time to switch over to Workbench. What I'm going to be doing is using the Synergy GENNET tool to make the bar chart that I've just created accessible to Synergy code. The GENNET tool interrogates one or more .NET assemblies and creates Synergy code that allows the classes within those assemblies to be used by Synergy applications. A special feature of GENNET is that it wraps Synergy's low-level .NET assembly API with code that's much more intuitive, easier to understand, and fun to use. Most importantly, using GENNET means that all of the code that we wind up creating and writing will be forward compatible with Synergy for .NET in the future. You'll notice that in Workbench I've already created 2 projects. One of the projects is called .NET Wrappers, and the other project is called Test Programs. There's no source code or anything pre-existing in these projects. The only configuration I've done so far is when I created the 2 projects. If we look in Project Properties in the Open Command tab, you'll notice that I've set a series of logical names that I'm going to use in my development environment. I have a logical name called bat, which is going to point to the location of a batch file that I'm going to create and build my wrappers. I have an src logical, that's where my source code's going to go. obj will be the target directory for object files. exe is where I'm going to create the ELB that will contain the wrappers that GENNET creates, and also in exe we'll have a Synergy DBR, a runtime program that we can use to test. And I've set my synexpdir and synimpdir logical names. GENNET creates Synergy classes, and when you're developing with classes, doing strong prototyping with the DBL Proto tool is a requirement. So the synexpdir and impdir are going to simply specify the location for the creation and importing of the prototype files. So we'll go ahead and close Project Properties. There are several steps involved in creating and compiling the wrapper code for the .NET assemblies using GENNET and the compiler and so on. So what I'm going to do is use a batch file to simplify the process so I can easily repeat all of these steps in the future if I need to. So in my Other Files folder, I'm going to ask Workbench to create a new file. I'm going to select that I want to create a batch file. I'm going to specify that it's created in my bat folder within my project that I created earlier. And I'm going to call the batch file buildwrappers.bat. Rather than typing manually a whole bunch of commands, I'm just going to paste in the commands that I created earlier, and then now we'll take a look through what these commands actually do. First of all, you can see we're using the GENNET tool. What this tool is going to do is interrogate the various .NET assemblies that I'm telling it that I want to use and create synergy wrappers, synergy classes that expose the functionality in that .NET assembly. So here you can see that I'm asking GENNET to process the .NET assembly exe.net forms.dll. If you remember when we created the .NET assembly, we asked it to create the output DLL in the exe folder, and my exe logical points to that same folder. And I'm asking GENNET with the -o option to create the output file in the src folder called .NET wrappers.dbl. So this is going to be the source file that gets created, containing the synergy classes that expose the underlying .NET functionality. Once we've got those wrappers in place, they need to be prototyped. Strong prototyping is required for OO development, so we use the DBL Proto utility to prototype and create header files that document the various classes and so on that are present in that .NET wrappers file. The DBL Proto is going to create a whole bunch of header files, and the location of those files is what we were setting earlier when we set the syn.exp.dir, Synergy Export Directory location. Once we have our prototypes in place, we can then compile our wrappers. Any code that you create with the GENNET tool must be compiled with the special compiler option -qrelax::interop. You can also see that I'm specifying the source code that I want to be compiled, and I'm compiling in debug mode and placing the object file into obj::.NET wrappers.dbo. Finally, because this is a fairly small assembly, I'm using an ELB. I'm using the dblink command to convert the object file for my .NET wrappers into an ELB called .NET wrappers.elb, which will also be located in the exe folder alongside the .NET assembly. In order to give me an easy way of building or executing this batch filing workbench, I'm going to go to the project properties for my project, and on the Tools tab, I'm going to select the Build tool, and I'm going to ask that the Build tool execute the build wrappers.bat file, and I'm going to specify the location of that using an environment variable BAT so that it can locate the file, and it doesn't matter which directory I happen to be in at that point in time. With that in place, we should be able to generate and compile and build our wrappers. So if we ask Workbench to do a build, that will execute our batch file. You can see there's GENNET, DBL Proto, DBL, and dblink executing. Didn't see any errors there, so we should be good to go. If we briefly take a dip out of Workbench into Windows Explorer, we should find that in our source directory, we've got several files that have been created. GENNET can, if you, depending on the assemblies you're using, can generate an enormous amount of source code. So what it does is it actually splits the source code into more manageable unit sizes. So you'll notice it's created a file called .NET wrappers1.dbl. That's where the actual code is. Had the code been much bigger or more extensive, it may have also created .NET wrappers 2, 3, 4, 5, and so on. And the .NET wrappers.dbl simply includes those individual source files. You'll also notice that it's created a .NET wrappers.inc file. This is an include file, and if we look in that include file, we will in a moment, we'll see that there are the various import statements for the various namespaces that have been created, so that we can then easily use the wrappers that have been created. So we'll use this include file in our applications. Let's switch back to Workbench and just for the sake of it, add those files to our project. So I'm going to go to Source Files and add an existing file. We'll go up and look in our source folder. I'll just include the .NET wrappers1.dbl. That's where the actual source code is. So that now appears under source code. And under header files, I'm going to add the include file. So again, we'll go to our source directory and add the .NET wrappers.inc. So here's the source code that GENNET created. This is a bunch of synergy classes that basically represent the classes in the .NET assembly. Here you can see we've got public class bar chart. So here's our bar chart class. Remember, bar chart was our Windows form. So this is the class that we're going to manipulate from Synergy. If we look in our include file, here are the various namespaces that are either required directly by our assembly. Our namespace, we didn't specify one, so it's defaulting to the name of the assembly, .NET Forms. and various other namespaces with various other classes that are required in order to use that form. So we don't need to really put too much thought into all of the nitty-gritty complex detail about what do we need to import to use these things. GENNET takes care of it for us. So let's close those source files. Typically you don't really need to even look at those things. You can pretty much just compile them and off we go. We hopefully, if we switch back to Explorer in our object file, our object folder, we'll find there's the objects for the compiled classes. We should also, in our headers folder, see all of the prototypes for the various classes and types that were created by GENNET. These are all the things that under the hood are required to use the classes that we've just created from. And hopefully in our exe folder, you'll now find that we have an ELB called .NET wrappers.elb. So that ELB contains the various classes that I can now use from other Synergy applications to load, display, and manipulate the forms within our class library. Obviously, right now we just have that one bar chart form. Okay, let's switch back to Workbench. Now we're ready to start creating a simple Synergy program to load, display, and interact with the .NET form that we created earlier. So we're done with our little batch file to build our wrappers for the time being. Let's close that. Let's shrink down the .NET wrappers project so it's out of the way. And let's switch our active project to our test programs project. Similar to the .NET wrappers project, this is just a standard Synergy DE project. I have done a little bit of pre-configuration on the project. If we look at its project properties, again, we'll see in the Open tab that I've taken the opportunity to set up the environment variables for the standard development environment, basically pointing to all the same folders that we used earlier in the .NET wrappers project. I've also configured the project's tools so that when we say compile, we're using a compile statement that uses the obj and src environment variables. Same with build, we've got a db-link command that uses xe and obj and exe .NET wrappers.elb. So you'll notice that I've set the link to link against the ELB that contains the wrappers that we created earlier. And similarly, the exit tool uses dbr of exe : to locate the program. Other than that, this is a standard Synergy DE development project in Workbench. No source files exist in the project at this point. So what I'm going to do is go ahead and create a simple test program. I'm going to add a new file to my source files folder in Workbench, select DBL as the file type, and name the program testgraph.dbl. I'm going to ask Workbench to place the source file in the src folder in my development environment and go ahead and create the file. Just so that we don't have to type a whole lot of really regular Synergy code, I'm going to paste into this new program a simple stub for the test program. You'll see it's a mainline program called testgraph, and really all this code does so far is open up the terminal, disable the stop message. It has a little message in there saying press a key to display a chart, and then waits for a key press. So before there, we're going to add some code to populate two arrays of data to be displayed in the chart. If you remember earlier, we had a method that allowed us to pass an array of labels and an array of values. And then once we've accepted the key press, we'll actually add some code to display the Windows form and load the data into it and display the graph. So to use the assembly that we created earlier, the first thing I'm going to do is go right up to the top of the source code, and when we're using classes, GENNET generates Synergy classes that allow us to access the underlying .NET classes, and we need to import the namespaces that are required. And if you remember, GENNET created an include file with the .inc file extension for us earlier that had all the necessary import statements. So I'm going to insert my .include of src:.NET wrappers.inc right at the top of the program before the main program declaration. The next thing we're going to need is to declare those two arrays that we're going to use to pass the labels and the column values into the chart. So I'm going to go down into my record area that I've already got defined in the program, and again I'm going to paste in a couple of arrays, one called months, one called sales. You'll notice the way these arrays are declared with the # symbol. These are what are called runtime arrays. This is a new feature that was introduced in Synergy in version 9.1, and you can find further information about those in the Synergy 9.1 new features web education session. Essentially, a runtime sized array is, as its name suggests, an array that I can add a line of code at runtime to determine the number of elements that exist within the array. Another thing we're going to need is an object variable to allow us to refer to our .NET form, or create an instance of our .NET form and refer to it. So I'm going to add a variable called chart, and you'll notice the data type is @varchart. The symbol used in this way in Synergy is a way of referencing a class. So the chart variable is an object variable which is going to be used to refer to an instance of the varchart class. The varchart class, if you remember earlier, was the Windows form that we created back in Visual Studio, and the class that we've created wrappers for using GENNET. Next, I'm going to add a little piece of code to declare the size of the months array and populate the values of the elements of that array with the labels that I want to use at the bottom of each column in the chart control. So again, I'm going to paste in a little piece of code. You can see that we declare the array as being of 12 elements. We use the new keyword to initialize the size of a runtime array, and then we've got code that populates each of the 12 elements of that array with the appropriate label for the column in the graph. Out of interest, because this is a runtime sized array, I can declare it to any size I want at runtime, and the code that we added to the Windows form earlier basically looks at the size of the array and uses that to determine how many columns will be displayed within the graph control. Of course, we also need to declare the array of values. So again, I'm going to paste in a little bit more code now that basically does the same thing with the sales array. You can see we initialize the sales array to an array of 12 elements, and then we have code that populates the 12 elements of the array with random values that we're going to use as the values for the various columns in our chart. Now we're ready to actually create the instance of the chart control, configure its properties and so on, and display it within our Synergy application. So I'm going to go down below the prompt to press a key to display the chart, and I'm going to add some code, first of all, to create an instance of the varchart class. In other words, an instance of the .NET Windows form that we want to display. So I'm going to use the object variable that we declared earlier in the data division, chart, and I'm going to use the new keyword to create an instance of the varchart class. And that's how we create an instance of an object in Synergy. If you remember, we added some code to the Windows form. One of the things we added was a property called title that let us set the title of the Windows form. So now I'm going to add some code to interact with that property and in fact set the value of that property. You'll notice because I included the generated source code in my Workbench project that I am getting IntelliSense from Workbench, and I'm going to set the title of the Windows form to sales analysis. We also had a property that was legend text, the text to be displayed in the legend of the chart. So let's also set that property to a value of, let's say, last year sales. And that will be the legend that gets displayed within the chart control. The final step before I can display the window is actually to pass the data into the chart control. Remember, this is going to determine both the number of columns that get displayed, as well as specifying the label for the bottom of each column and the value for each column. And the way we do that is using the chart.setChartData method. So chart.setChartData, there's the method. We open paren, it wants an array of strings for the labels. That is our months array, and finally an array of ints for the values, and that is our sales array. That's everything configured. Now I should be able to display and show the chart, and the way I'm going to do that, because our chart control is actually a Windows form, I can simply use the standard Windows form show dialog method, which will actually show the chart and wait for the chart to close itself. And if you remember, we added a close button that closes the form. So let's add our chart.showDialog method call, and that will cause the form to be displayed in a modal fashion until such time as it closes itself, because the user clicks on the close button. Okay, that's basically it. So a brief review of what we did here. We added our .include of the file that GENNET created that has all of the import statements needed to use the form. We added 2 arrays of data that we're going to pass to the form, and an object variable called chart to allow us to refer to an instance of the form. We added some code to populate the months array and the sales array. And finally, we added the code to create a new instance of the Windows form, set the title property and the legend text property, and then call the setChartData method, passing the two arrays of data. Finally, we use chart.showDialog to show the Windows form as a modal dialog within our Synergy application. Okay, let's go ahead and use the build menu to compile our program. It compiles without any errors. Let's also hit the build option to perform our link. Again, noticing that we are linking against our .NET wrappers.elb that we created earlier. That's the thing that has the wrapper code in there. And finally, we can execute the application. So here's our Synergy program running. If you remember the code, we've been through the code that's populated the arrays. At this point, we're ready to create the instance of the Windows form, set its properties, and call its show dialog method. So let's go ahead and hit a key. And there we get the Windows form popping up. It is a modal dialog, so the application at this point can't do anything else until we dismiss the form. You'll notice the months array has been used to populate the labels. The sales array has been used to specify the various values for the columns. Here is the legend text that we passed in. And if you remember, we also used the chart.setTitle or chart.title property to set the title of the dialog. When I press the close button, if you remember, the Windows form had code to say when the button is clicked, close the form. So we close the form and our Synergy application closes. Let's just take a moment to review the three basic steps that we used to create this demonstration. First of all, we used Visual Studio to create a class library project. A class library is an easy way of creating an assembly. Our class library contained one class, essentially, a Windows form called bar chart. We added some visual components to that Windows form, and we added a little bit of code behind the scenes, A, to allow the form to close itself when the close button is clicked, and B, to expose a couple of public properties and a public method. And these were things that we could access from Synergy in order to set the title of the Windows form, the label on the legend, and pass in information by calling a method to populate the rows and columns, if you like, of the graph control. We then compiled that project into a DLL. Once we had our .NET DLL, we used a Synergy project in Workbench, basically as an easy way to allow us to create this batch file. The batch file performed a GENNET operation, so it basically looked at information about the .NET assembly and created Synergy wrappers. We then prototyped that wrapper code. Prototyping is required if we're dealing with classes in Synergy. We compile the resulting code with QRelax interop, and we link it into an ELB. Finally, we used a second Workbench project called Test Programs, and we created a simple test program to actually launch the Windows form using the wrappers that GENNET created for us. And you can see how simple the code is.